Hello, my wonderful students. How are you doing today? I hope you are enjoying your stay at home. Today we are going to go back to basic science, and we have run through energy. We have talked about the kinetic and the potential energy, and we have done some calculation on that. Today we'll be looking at another topic, which says the formation of a chemical compound. But before we go into that, we'll just take correction to the last assignment given. The last assignment says a student of mass 10 kg is moving at a constant velocity. He has kinetic energy of 50 joules. Calculate his velocity. So that's the correction now. The correction. Ke was given, and that's 500 J. Mass was given 10 kg. Then we are asked to calculate the velocity, V. The formula, we said that Ke, which is kinetic energy, is equals to 1/2, or you can say half, times m times v square. You can say v times v. V square is the same thing as v times v, not v divided by 2. Okay, so you have it. Two will divide itself to give us 1. 2 divide 10, 5. And we have 500J is equals to 1 times 5 is 5. 5 times v square will give us 5v squared. Now we'll divide with the coefficient of v squared so that we can make v squared the subject. So the coefficient of v squared is what? 5. You can see it here, 5. So we'll divide both sides with 5. And we are left with 500 over 5. 5 will divide itself 1. 5 will divide here 1. So we have we got 100 equals to v squared. But remember, you are asked to calculate velocity, not velocity square. So what do we do to this? We'll find the root of 100 so that we can now eliminate this square here. So that will be, let me clean up, root of 100 will be equals to v. So we will now say what number will multiply itself to give us 100. 5 times 5 will give us 25, so it's not 5 times 5. 9 times 9 will give us 81, so it's not 9 times 9. 10 times 10 will give us 100. So meaning that 10 times itself will give us this. So meaning that 1V will be equals to 10 meter per second. So if you have this, you mark it correct. I've seen some of your assignments submitted to me. Some of you did well, while most people did not do well. So please, if you want to do this calculation, make sure you follow the step. Use the formula and follow the step, and you will get it. I wish you good luck. So today, we'll go straight to what we have for today. Remember, I said today we'll be talking about formation of chemical compounds. Chemical compounds. By the end of this lesson, it's expected that you will know how to define 1, the chemical compound, 2, an element, mention some elements, write their symbols, and also know what a valence is. Because without the valence, you will not be able to form the chemical compound. So we'll start by defining the compound. Then as we define the compound, we also define other things. So what is a compound? A compound is a substance that is made up of 2 or more elements that are chemically combined together. I repeat, a compound is a substance that is made up of 2 or more elements that is chemically combined together. During our classes in our JSS 1, we talked about matter, where we discussed matter as anything that has mass and occupies space. And we said that this matter can be a living thing or a non-living thing. So when we are discussing the non-living matters, we said that these non-living matters can be simple or complex. And we said that the simple ones are the elements, while the complex matters are the compounds and the mixture. So compounds are gotten from elements. Remember, the definition says is a substance that is made up of 2 or more elements that are chemically combined together. Meaning that we must know what an element is before we can form a chemical compound. So what is an element? An element, from what I said earlier on, I said it is a simple form of matter. So an element is a simple form of matter which cannot be split into any simpler form by any ordinary process. You can say that an element is a substance that cannot be divided. When you say split, it means to divide something. So you cannot divide it. It cannot be splitted by any ordinary process. You can't split it into any simpler thing by any means. Okay, so that's what an element is. Now, we have a lot of elements. There are a lot of elements. If we open our chemistry textbooks, we'll see a lot of elements. But at this level, I want us to know more about the first 20 elements. Then we can also talk about the polyatoms. Because as we are forming these chemical compounds, we'll also make use of the polyatoms. So we'll learn the first 20 elements now. We'll learn them. We'll learn their atomic numbers. We'll know their symbols. Then we'll draw their atomic structures. We'll write their electronic configurations. And from there, we can as well get their valency. When you hear me say valency, valency has to do with the combining power of an element. That thing that will help an element to combine with another element to form this chemical compound. That's the valency. So we'll start by, first of all, naming the first 20 elements. I want you to follow me in this song. I will just sing it, then I will write them out. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are the first 20 elements. You know, when we are writing our ABCD, you notice that we'll write A, B, C. When we write it this way, we say that we are writing it in alphabetical order. I write Ada, Obi, Chioma, and I say arrange these names in alphabetical order. You notice that you write Ada first, Chioma second, then Obi third. Why? Because we are following our alphabet. Now, these elements are arranged according to their atomic number. If I want to say, write numbers to these alphabets, you notice that A will have number 1, B will have number 2, C will have number 3. This same thing with these elements. The elements are already arranged, let me borrow this alphabetical order, in alphabetical order, which we refer to as according to their atomic numbers. So when you misplace them, then you notice that you are placing them wrongly. If you take one element and put it against another number, you are placing that element wrongly. Just like if I want to write my ABCD, after this C, I'll write G. Then I'll write Y. You notice that I've placed G and Y wrongly. So we must follow it according to their atomic number. So let me write out these elements. Okay, when you look up, you can see their symbols. Almost all the elements has their symbol gotten from their first letters. The first letters. Like hydrogen, the first letter for hydrogen is H. So that's the symbol H. Helium, if you write another H here, you'll be confusing yourself if this is hydrogen or helium. So that's why you have to have something to differentiate both. So helium is He. You can see that when writing these symbols, they must be in capital letters, except those symbols that has 2 letters. The first one must be in capital, while the second letter will be in small letter. Like this helium, you have He, capital letter H, and then small letter E. This Li, you have L, capital letter and small letter I. Then another thing also you will observe is sodium. The symbol should have been SO. Even potassium, the symbol should have been PO. But you notice that their symbol, they are different. Their symbol are not gotten from their first letters. Why? Because they have Latin names. So their symbol we are gotten from their Latin name. So while writing a chemical compound, we must use these symbols. We use their symbol to write this chemical compound. There are things we need to know that will help us to form this chemical compound. One is the valency of each element. What do I mean by valency? I know I've said it earlier on that valency has to do with the combining power of an element. That thing that will help an element to combine with another element to form a chemical compound is what we refer to as the valence. Okay, now before I'll get the valence of these elements, I'll be able to draw their atomic structure, or I'll be able to write their electronic configuration. I must be able to draw the atomic structure or the electronic configuration. Each element can be represented in a structure or with a structure. Now, an atomic structure is this way. It's made of a shell with a nucleus inside. An atomic structure is made of a shell with a nucleus inside. Now, this shell can run from K, L, M, N, and so on shells. What do I mean by that? I can have shells like this. This is my K shell. This is my L shell. This is my M shell. This is my N shell, and so on. This K shell, L shell, M shell, N shell. So one thing I must know as I'm drawing my atomic structure is these shells. Each shell has a particular number of electrons it can take. So you don't put any number of electron in any shell. No. Like for instance, K shell can take the maximum of 2 electrons. It cannot take more than 2 electrons. So when K shell has 2 electrons, we say that it is completely filled, that the shell is complete. It has attained what we call a duplex level. Then this L shell can take up to 8 electrons. You may be saying, what do I mean by this electron? Electrons, they are negatively charged atoms we see running around the nucleus of an atom. Now remember I said that as we are drawing this atomic structure, that one thing we should notice is the shell, another thing is the nucleus, located at the center of the atom. This nucleus comprises 2 things: the positively charged proton and the neutral neutron. What do I mean by neutral? Meaning it does not have any charge. So you have the proton and the neutron in the nucleus. Then you have the electrons revolving around the nucleus. I don't want to go deep into proton, electron, and neutron, but I just want to leave you with this, that this proton, neutron, and electron, they are the 3 fundamental particles of an atom. They are what? The 3 fundamental particles of an atom. So as we are doing this, you'll be hearing me say number of electrons. Okay? So this K shell takes 2 electrons. So you can hear that electron now. Then L shell takes 8 electrons. So I don't put more than 2 electrons in this K shell. If I do that, I'll be wrong. The highest number of electron I'll put here will be what? 2. It must not exceed 2 electrons. Then in this L shell, it must not exceed 8 electrons. Let's give it a trial. Using what we have said, I believe you must have copied these elements. I will just clean the elements. Maybe we'll leave the symbols and the atomic numbers, because they will help us now as we draw the structure. Let's pick the first element. Let's draw the structure of this first element. You have the structure of first element. Remember I said you must draw the shell and the nucleus. The nucleus must be there at the center. Then when you look at this number 1 element, you can notice that it has just 1 as its atomic number. 1 as its atomic number. So this number of atom here is what we are representing here as the number of electrons. So this number of electrons will be equal to the number of atoms represented here, the atomic number. Okay, so here we have 1 because the atomic number is equal to 1. The next one, you have 1, 2, because the atomic number is 2. Now, seeing that this one has 2 electrons, remember what I said here, that this K shell can take highest 2 electrons. That's the highest, the maximum number of electrons it can take. It now means that this shell is completely filled. This shell is completely filled. It has attained a duplex level. If we were to draw a periodic table, you notice that this element, I will place it in in group O, or I will say group 8. That's the noble gases or the rare gases, or you can call it the inert gases. We call them the noble gases because they have completely filled electrons. Their outermost shell is completely filled. So because they are completely filled, they are highly unreactive. What does it mean? Meaning that they cannot give out electrons, they cannot take electrons. So because they cannot give out electrons and they cannot take electrons, we say that they are highly unreactive. So this one, which is helium, is completely filled because we said that this first shell is K shell, can only take 2 electrons. This is the maximum number of electrons it can take. So the next one we will now draw, which is lithium, you notice that we'll draw it this way. My K shell, 1, 2. Then the next shell, which is L shell, will now come up. I will now put 3. 1, 2, 3, which is the number of atom. That's the atomic number for lithium. So this is the atomic structure for lithium. This atomic structure is just like you are representing this atomic number with structures. You are representing it using structure, no longer writing numbers. Now, but the only thing you need to notice is how to fill the structures. You don't just write any number. The first one takes 2, the second one will take 8. And as I'm filling this second one, I must fill it accordingly. As it's taking 8, I will not just draw 8 electrons all over. No. I will first of all draw 4. Then I will now come and now fill it again. What do I mean by that? For instance, if I have an element that has 10 as its atomic number and I'm asked to draw the structure of this element, I will now draw 1, 2, 3, 4, 5, 6. Let me draw it. Now look at what I've done. 1, 2, 3, 4. Why do I have to do this? Because I know that this L shell can only take 8 electrons. And then these electrons, I will fill them singly first before I will start pairing them. So knowing too well that I will have to pair them, I will now ask myself, oh, what number will I write 1, 1 and I will also pair it? The pairing meaning writing them 2, 2 now. They will now still be the same. I will now notice that the half of 8 is 4. So since the half of 8 is 4, I will first of all write 4 electrons. Then I will now come and say, since I still have more of electrons remaining, I will now say 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, this 9 electrons now. If I may ask, which element has this structure? Which element? Is it oxygen? No. Why do we say it's not oxygen? Because oxygen has 8 as its atomic number. So it's not oxygen. Because what we have here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So which element has 9 atomic number? I will look at it. I can see fluorine. So this is the atomic structure of fluorine. This is the atomic structure of fluorine. So we can go on and on to draw other elements, representing them in structure using their atomic number. I'll just draw the first 10, then you will help me draw the remaining. Now, if we can finish the drawing of this atomic structure, from here, we can just get out their electronic configuration. Even from the atomic structure, we can as well get their valency. Okay, the first one, don't forget to write the name. This is hydrogen. The second one, this is helium. One, two, three, four, 5. Which element is that? Number 5. I have hydrogen number 1, helium number 2, lithium number 3, beryllium number 4, boron number 5. So this is boron. Number 6 is carbon. Permit me to clean this. I believe you must have written it down. Now you can see that this one is 1, 2, 3, 4 in the outermost shell. The outermost shell means the last shell, the shell that is outside, the last shell. The last shell here has 4 electrons. So I will now start pairing for the next element. So I will now pair. I have 1, 2, 3, 4, 5, 6, 7. So which element has that? That's nitrogen. You fill it singly before you start pairing. This is oxygen. Now you can see this last one here, that the shell, the outermost shell has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 electrons, meaning that the outermost shell, which is L shell, is now completely filled. So the next one you'll be drawing, means that you will draw the next shell. The next shell will be what? The next shell will be what? After L is what? M. So the next shell will be M shell. So the next element now you'll be drawing, you draw the next shell. That is like this. 1, 2. Let me clean this first one and do it up here so you see it very well. Okay, go with me now. The next shell is sodium, and sodium has 11 atomic number. So meaning we are going to represent this 11 here. So the first one, which is K shell, has 2 electrons already. So the next one is L shell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I will draw the next shell. Why do I have to draw the next shell? Because this one is now completely filled. It's now completely filled. And because it's completely filled, I will draw the next shell. Okay. I will not say, let me put here. No. This L shell can only take 8 electrons. It will not take more than 8 electrons. The next one, I'll put it here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that is the structure of sodium. So do the rest. Okay. Your assignment will be to draw the remaining atomic structure. That is magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Remember, the first shell can only take 2 electrons. The second one, even the next one, will take 8 electrons. So don't put more than 8 electrons in K and in L and M shell. It is only K shell that can take 2 electrons, then others will take 8. Make sure you follow the rule. If you follow it, you'll be able to draw the structure very, very well. Okay. And from this structure, like I said before, we can get our valency. I think we'll do that in our next class. With that valency, we'll now combine different elements to form a chemical compound. Don't forget how we started. We started by defining a compound. We said that a compound is a substance that is made up of two or more elements that are chemically combined together, meaning that you have one element combining with another element to form a chemical compound. And we'll now say, what do we mean by an element? We say that an element is a substance which cannot be split into simple units by any ordinary process. Just like we have these elements here, you can't split them, you can't divide them into any simple units by any ordinary process. Okay, and then we went ahead to mention at least the first 20 elements. At least I believe in this level, or at this level, you should know the first 20 elements. And we have mentioned them. We even sang the song. I know some of you will still remember the song, but peradventure you've forgotten it. You can still recall it now. Then we have the symbols. And I told you that these elements are written just like your ABCD is written in alphabetical order. These elements are also written according to their atomic numbers. We don't place them wrongly. We must place them according to their atomic number. Like, for instance, I have number 8 here, which is oxygen. I don't take hydrogen and put it in number 8. No, that will be wrong. So we must write them accordingly. Just like in our alphabet, we will not be writing A, G, H, Y. No, we will not write it that way. If we do that way, people will say, I hope this person is feeling all right. So that's something applicable here. We will not write it that way. We must write it according to their atomic number. And remember, we said that atomic number is the number of protons contained by all these elements. The number of protons contained in an element. Okay, meaning that the number of protons is equivalent, or is the same thing as the atomic number. And then we went ahead to talk about the atomic structure. And we said that the atomic structure, there are two things you should notice about the atomic structure. They are, one, the shell, and number 2, the nucleus. You can't draw the atomic structure without the nucleus. You must draw the nucleus, and you must also draw the shell. And we drew the shell. We say we have several shells. We have the K, L, M, N, and so on shells. Then we have the nucleus at the center of this shell. This nucleus, I said, it has two things, two particles in them. They are the proton and the neutron. The proton is positively charged, while the neutron has no charge. It's neutral, meaning it has no charge. Then electron is found revolving around this nucleus. Electrons are on this shell revolving around the nucleus, and these electrons are negatively charged. So knowing this now, we also said that each shell has a particular number of electrons they can take. That K shell can only take maximum of 2 electrons. Then L shell, even M shell, can take 8 electrons. When we get to our senior secondary school, there's something we also learn, which is the rule. We have several rules. We have the Horn's rule, we have the Archimedes rule, and so on. But now, I just want to tell you the number of electrons each of them will take. If we are talking about that rules, we have to talk about the energy level. We are not going there now. Okay, so we said that K shell will take 2, then others will fill with 8 electrons. And knowing too well that it's 8 electrons, what do? We said that we'll fill them singly first, meaning we'll fill them 1-1. After filling 1-1, and we still have electrons that we need to fill, we'll start pairing. For instance, here we have 1, 2, 3, 4, 5, 6, and 1 electron was still remaining. We had to pair it. So that's something applicable here. So I want to believe that you must have understood what I said. So I want you to try this one. If you tried MG, L, AL, sorry, you try MGS, AL, SI, P, S, Cl, Ar, Ka, and Ca. You must write their atomic number by the side, then you write their symbols. You write the symbols, like this one, you write the symbol, you write equals to 11. I'm just drawing it because I've given you the atomic number already. That's why I had to draw it without writing the number. So if you draw your own, I want to see the atomic number. So once I look at it, I will know if you are correct or not. I wish you good luck. Stay safe.